So my paper is distant supervision for medical concept normalization. So what is medical concept normalization? It's mapping informal medical phrases to formal concepts. So I am losing weight is an informal colloquial phrase that could be mapped to weight loss, which is a concrete SNOMED concept. So obviously this is widely applicable, but in this paper we're going to be focusing on processing social media forums, which is a fast-growing platform with participation from all members of the healthcare cohort, patients, doctors, providers. So our recent studies have shown effectiveness in leveraging this data for finding side effects for drugs, detecting infectious disease spread, and monitoring public health and understanding patient experience. So this image in the slide shows social media phrases mapped to normalized medical concepts. So what's the problem presented in the original paper? So medical concept normalization is typically formulated as a supervised classification problem, but this can get very tricky when you're scaling these models to millions of medical concepts, and it involves large costs because you're manually creating extremely large data sets. So, and when medical concepts are added, these models need to be entirely retrained from scratch. So the proposed solution presented in the paper and that I implemented in my implementation is training MCN models using automatically labeled examples extracted from medical knowledge bases. So this involves computationally creating a distantly supervised dataset from patient discussion forum posts. So this data set is more adaptable, and because it's not being manually created by possibly a biased user, it's more robust to different types of concepts and different phrases that you could find in the discussion forum. And the experimental results show that MCN models trained using the proposed solution outperform the baseline significantly in terms of classification accuracy. So the overview of this implementation is the main part of it is the creation of the distantly supervised dataset. So first we scrape the patient discussion forum website to extract medically relevant noun phrases. Then we use a medical entity linker, Metamath, to map those phrases to UMLS Metathesaurus concepts, and then we filter the resulting dataset by calculating embeddings and only keeping the K highest cosine similarity phrases for each concept. And lastly, we use that to train a two-layer feed-forward neural network for predicting the concepts from input phrases. And this mirrors the implementation in the original paper exactly. So in collecting the noun phrases, we scraped 10,292 posts from the patient.info/forums website using Scrapy, open source data scraping tool. So, and then we used the Stanford NLP linguistics analysis package, known as Stanza, for extracting noun phrases from the content we were able to scrape. So these are the same tools that are used in the original paper. So for medical entity linking, Metamath is a publicly available tool for this, provided by the National Library of Medicine. So it's a batch tool, so you can submit a CSV of data, and it'll give you the results. So you can see in the image, it's mapping medical phrases to associated SNOMED concepts. So after the medical entity linking, we have phrases and concepts, and we calculate the cosine similarities between their embeddings, and then for each concept we take the K highest cosine similarity phrases. So we calculate these embeddings using the sentence transformers library, which is documentation that the link provided, and the value of K for K nearest phrases is empirically determined, and in the original paper they observed the highest performance with K equals 9. So the resulting supervised dataset after The computations in the previous slides consist of the following data points: concepts, phrases, cosine similarity, and MMI score, which is the Metamath indexing score, which is the relevance of the UMLS concept to the phrase, and then also the identifier from Metamath. So the dataset used for the test dataset is CADIC, which is the Adverse Drug Event Corpus dataset, and this is a publicly available dataset obtained from askapatient.com discussing adverse drug reactions that resulted from their usage of those two drugs, and it's provided by the Australian government. So the data points we extract from this dataset is phrases and concepts, and those are used to as the evaluation on the two-layer feed-forward neural network model. So this neural network model mimics the one in the original paper, and in the first stage we take the medical concepts from SNOMED and encode them into fixed size embeddings, and then each input phrase is transformed into an embedding vector using a pre-trained sentence transformers model. And the third stage, the vector is passes through the neural network and is transformed to a vector in the target embedding space. And the parameters in this model are optimized using the AtomW stochastic optimizer and cosine similarity loss. So we're trying to maximize the cosine similarity between the resulting vector from the output of the neural network and the target concept vector. And during inference, a new input is mapped to a vector in the target embedding space, and this is classified to a concept using a one nearest neighbor approach. So as for the results, our statistics on cosine similarity in the supervised dataset between concepts and phrases were similar to that of the dataset constructed in the original paper, but the classification accuracy fell short of the original paper, likely due to a much smaller dataset size, and we were unable to obtain the SNOMED CT synonyms dataset, which was used to train the model in the original paper on top of the distantly supervised dataset. So the original paper also compared the differences between different types of embeddings, whereas in this implementation we focused only on using BERT for embeddings. And here are the two references. First is the original paper, and the second is for CADIC, the test dataset. Thank you.